Okay, so I think we're live. Hello, everyone. Welcome on WJUG online edition. Today we are together with Marcin Grzejszczak, and I will pass voice to Michał.
Yeah, hey. So today we have Marcin with his presentation about tracing issues in applications, in your application. This is one with 181st meeting of WJUG. Next thing, our partners for today are JetBrains, who provided us with JetBrains licenses, Deserto that provided us with some books, and Society that provides us with prizes for you. Society provides the workshops. As we have some announcement that we have to make. We are looking for ideas. If you have any idea that you would like to do with us, like workshop or some kind of or something that would benefit our community, please talk to us. If you have like only an idea, we are really would like to hear them and make them possible and realize them in the future. And next one, we are looking for speakers always about various topics about Java, JVM architecture, databases, soft skills in IT, IT to business relations, and many more. We're looking for any level of experiences from speakers. So, and we'll find a suitable audience for you. And we're looking anything from 15 to 120 minutes. So anything from flash talks to deep dives. Okay. You can find us at Slack and those email addresses, Twitter, Facebook, Meetup, and the web page. I think that's done.
Okay, so small announcement. After Marcin declared that after our event, we can meet in small after party and drink beer and talk more privately. So if you would like, wait till the end, and we will send you a link to Google Meet, and we will chat with our speaker there. So wait till the end, and that's all. Marcin, I think stage is yours.
Thank you. Okay, so I should, I guess, share my screen.
Yeah.
Somehow. Wait a second.
Awesome.
So let me go here. Share. Okay.
Okay, so we can see it. So
can you see my screen?
Yeah, we can see it.
Okay.
So stage is yours. We are muting ourselves and go on.
Thank you so much for being with us today. I mean, you could pick any Netflix TV show or do anything else, but you decided to spend this evening and listen on how to trace issues in your application. I'm really happy that you made this decision. So if you don't know me, a couple of words about myself. So my name is Marcin Grzejszczak, and I work at VMware. I used to work at Pivotal. Pivotal got acquired by VMware, so there I am, and the Spring Cloud team. And I'm working mostly on two projects or two areas, because it's not only one project. One area is distributed tracing, so Spring Cloud Sluff. I'm the lead of that project, and contract testing, Spring Cloud Contract. I'm also the lead of that project. In general, I have given quite a few presentations, so I had a year and a half, more or less, pause in giving any presentations to the community. In general, I've given, for sure, since 2014, over 100 presentations. I authored 2 books about testing, and you can find numerous courses at the O'Reilly platform, including Applied Continuous Delivery or the 10-hour course about Spring Cloud Contract. Also, I'm the co-author of the Smart Testing course. If you're interested in learning about how to test, you can check that course as well. If you want to reach me out, you can join me at Twitter at Grzejszczak. I know that today it's in English. I know there's already quite a few people, not necessarily from Poland. I can see somebody joining from Orlando, so hello. You can have a problem in actually finding me on Twitter because of my last name, but if you type 3 first letters, most likely you're going to find me. If not, go to my blog, toommuchcoding.com, and you will definitely find the Twitter handle and other contact methods there. If you see me look to the right, it's because on the second screen I'm looking at the comments in the meantime, so it's not out of disrespect. I have the camera here, but I'm also looking at the other screen. So welcome everybody. There's somebody from Boston, so welcome as well. Okay, so let's get it started. We have a couple of people, exactly 2, that I would like you to meet. So first, meet Joe. So Joe is a demanding internet user, and he wanted to search for memes. So that was his goal in his life. And meet Jane. And Jane is a programmer who has been developing that particular meme generation system. So what Joe wanted to do is search for interesting memes. This is what you have to do when you have a meme generation system. And at first, things went really, really smoothly. So Joe was searching for memes, and he was able to find an interesting meme. I will not translate this from Polish, because initially when I created this presentation, I didn't know that it's going to be like so broadly available. At the after party, I can surely explain this. This was one of the, let's say, most frequently shown types of memes out there in Poland. Let's not get into details of that. But yeah, whatever. He found the meme he was interested in, and that's great. So the state of bliss didn't last long, because eventually Joe saw this. So 500 response code, blue screen of death, memes failed to generate due to server errors. A disaster. Joe was not happy. Joe was really, really frustrated. So Joe decided to file a ticket to the meme generation system. Now, Jane decided to investigate that. She saw the issue, she looked at the stack trace, and Jane wanted to know the truth about what really happened. Okay, we have a stack trace. We have some sort of a meme overflow exception. Okay, that's something, but it's really not that helpful. Jane wanted to know what Joe did that led to the error, right? This is the crux of the matter. This is the key thing that we want to have. Like, if we have a stack trace, it's not really that useful. We want to know what happened exactly that led to this particular error. So I lied to you a little bit, because the system is not, simple. This, let's say, image is not showing the truth, because, okay, let's say logically, we might have 4 services, but actually those services might be deployed on, let's say, various servers, various, let's say, physical locations, but also we can have multiple instances of those apps, right? So the question, like, where the problem happened is not really that easy to answer. What we can do, though, it's one of the ways to solve this problem, is that you go to, let's say, each of the servers you have, SSH there, do a tail for logs, and search for an error. Now, if you have 4 servers and 4 apps, I mean, yeah, you can do it. However, like, even if you see the stack trace, it won't give you much, right? Because you have the stack trace, but you know nothing else. The truth is that you don't have 4 servers. You can have multiple servers. Like, quite frankly, right now we're in a good situation, because you can buy those bended screens, right? So you can buy 5 of those bended screens, and then there's those curved ones, right? And then you can see like 500 windows with, tails, let's say, gripping of for errors in your system. And you can do it, but it's not really that helpful, and it's not easy to maintain. So Jane says it's okay, we have a problem related to production observability. Jane sees that there's really no proper feedback for production monitoring. she doesn't see anything related to the metrics, and nothing related to logging. Like she's missing critical information. So the two questions she's trying to answer right now is, what if the apps produce metrics about their state? This is one thing. The other one is there a way to correlate logs? Because the fact that we have some logs is not enough. We need to be able to tell the story of what happened. So let's start with the first problem. So Jean wants to address the metrics problem first. So let us assume we have those 4 apps. What if those 4 apps could, each of them, let's say, present the state of the, let's say, the health state of the given service, of the given server on which it's running the given JVM, right? So if that was the case, if each of those services was required to actually publish those metrics, what we could do is send the metrics out to the metrics store. Or the other way around, maybe the metrics store could actually scrape the metrics coming from all of those services. If that's the case, then our screen could be a little bit different, because now it's not only, let's say, an information that we have 4 services. Now we know that those 4 services are in some kind of a state. So if we click on a given, let's say, on a given app, on a given service, here service 2, we know that it's a Java app. We know the request rate, the error rate, and we can check out the whole dashboard related to the state of this service, like requests per second, like 0 per second. Maybe it's not the best service out there, right? Or maybe we don't have a lot of traffic. 44% of errors is bad. It depends, but it doesn't sound really good. What is really interesting is, for example, the P95, so 95 percentile showing you 51 years. That means that somebody had to start processing the request 50 years ago and has just finished. So yeah, you can find interesting information when the apps are starting to publish, let's say, the metrics about themselves. And you don't have to necessarily publish, let's say, those metrics that come out of the box, like, you know, like the ones that I mentioned, so the technical ones. The critical thing to remember is to actually publish the KPI-related metrics, so key performance indicator metrics, so the business metrics, because you can have like 0% error rate, you can have 100% of successful requests, a lot of requests per second, good percentiles, and nothing works on a logical level, right? So you should also have quite a few business-oriented metrics. So at least we have something, right? We can put alerts over those metrics. So let's say right now we are able to reason a little bit about our system. But let's try to actually solve the problem related to telling a story of what Joe actually did that led to this particular situation. So let's say we have those 4 services. And if we could start, let's say, when the request comes in, it would be great if we were able to actually define some sort of a correlation ID. Let's call it trace ID, and let's give it some sort of a number, 1, 2, 3, right? So first request comes in, and or a message from a broker that comes in, and we set some sort of an identifier. Let's say trace ID equal to 1, 2, 3. Now, let us assume that every single time the app or any of those apps are logging anything related to this particular business operation, we will attach this identifier somehow, right? So if the correlation ID, this trace ID was 1, 2, 3, we will attach this 1, 2, 3 to the logs throughout the 4 services. Now, the key thing to remember is that we need to propagate this information. We need to propagate this ID to other services. So we propagate it over the wire, and then when service 2 says hello from service 2, we will attach the same identifier to the logs, which means that the same should happen for service 3 and service 4. So this is, let's say, the context propagation mechanism there. You're able to set an ID at the beginning, and then you propagate it on to other services. So let us assume that we have those logs, and again, one option would be to go to each of the servers and tail for that particular ID. This is actually even better than the previous case, because if we have 4 services, we are able to find all the logs corresponding to that particular ID from all the servers, right? Of course, then you have to, let's say, copy paste them in the same spot and put them chronologically, which is kind of not very efficient. So let's not go that way. It's already better than it was previously, but let's not go that way. So what if we could actually push the logs to some sort of a log store, right? If you read about cloud native apps, you know that you should not actually log those, let's say put the logs into files, because the file system is ephemeral. What you should be doing is either piping it to the system out, and then you have some sort of a scraper that takes the logs and pushes them. Another option is just to do it like by yourself, that you push the logs somewhere. So let's say that we have the logs and we attach the ID, right? So now we have this trace ID attached. So then in tools like Splunk, Elk, like Elasticsearch, Log/Kibana, and all sorts of tools like that, you can actually put the logs together and let's say filter over the trace ID and put them chronologically in order. And then you can reason about the logs from various places, no matter how many services you have, how many servers. For the given business operation, you can reason about the problem. Here we know that somebody called an endpoint that should end up with a read timeout. So if somebody expected a read timeout, then they got the read timeout. This is why eventually Joe got the error 500 because a wrong endpoint was apparently called. So Jane's done. There's nothing else to be done, right? The problem was solved thanks to log correlation. It's time to start the weekend, although it's Monday, right? So let's get back to Joe. Joe wanted to generate a new meme. So he went to the meme generator. He wanted to search for some memes about cats. He wanted to click generate a meme, which he did. And he waited and waited and waited even more. Went for coffee and back and again. And then he got the cat. So yeah, I mean, the system is working, but it's not working fine. So Joe was really sad again. I mean, this is unacceptable, right? He paid nothing to use the software, but like again, anyways, he's using the software, so it should work. So the system is slow. So another ticket is filed, and now Joe is an experienced, let's say, open source user or like in general an experienced client, so he knows how to file proper tickets. So he went to GitHub, he found the meme generator project, and he decided to write a good descriptive issue. System is slow, the system is slow, please help. So Jane sees that the new issue is filed. Of course, it's not the worst description she has ever seen in her life, but it could be better, right? So now Jane says, okay, fine, I'm gonna, let's say, tackle this problem. I have the correlated logs, so for sure this is good enough for me to, solve this issue. So let's look at the logs. This line should not be called, logging something, logging more. It's very helpful. This should work. I mean, fine. Okay, sending a request, sending what request, really? I mean, if at the end of the day we're fetching this meme from somewhere, and then we're rendering it, so this is the first sending, or other requests that we have to make. So this is not really descriptive. Returning the response, is it the response for the request, or there's another request and somebody forgotten to log? Yeah. Did it take 10 seconds to render this? We don't really know, right? It's problematic. So what Jane says is, okay, maybe I can change the log. So now on, I will go to every single line of the code, and when I have some sort of an operation, I will change the logs to do this start, and then I will store the timestamp when it happened, and then when I get the response, when I have stop, I will take another timestamp and I will subtract one from the other, and then I will describe it in seconds in brackets so that I can parse it in the future and know that this particular operation called sending a request took 2 seconds. I mean, you can do it, but that's a lot of writing. That's a lot of writing. So Jane sees that, modifying all logs, that will take a lot of time, really. It doesn't scale. So there must be a better way to solve this. let's look at service 2. Maybe we're going to find an answer there. So we have service 1 calling service 2. Let's say it's a simple case, an application controller, an application service. And from the application service, we're going to be calling service 3 and 4, right? So this is the flow of the request. So conceptually, logically, here we have one operation, service 1 calling service 2 on the application controller side. This might be an operation. Maybe we want to know exactly how much time it took to call application service and get the response back. It's something that we should reason about, right? This is for sure an operation. So calling service 3 and calling service 4. These are all operations. So logically, we're able to depict how the flow of the system looks like and what kind of operations we have. And let's call them spans, because why not? So for each operation, we will provide an identifier, right? So when the first request comes in, let us assume that this trace ID, this correlation ID is equal to 1 to 3, but the span ID will be also equal to 1 to 3 because it's the first one. So the first operation has this identifier 1 to 3. Now, when service 1 is calling service 2, we will continue to propagate the trace ID 1 to 3. However, since we have a new operation, we will provide a new ID, like 2, 3, 4. When the service 2 is calling service 3, it's a new operation. So trace ID the same, span ID is going to be 3, 4, 5. And the same related to calling service 4 from service 2. So we're going to have span ID 4, 5, 6. Now, why do we do this? Because conceptually, a span with, for example, ID 4, 5, 6 will have the following information. Who was it? Was its parent? So in our case, that's going to be span number 2, 3, 4, because the flow is like this: 1, 2, 3, then 2, 3, 4, and then 2, 3, 4 creates 2 child spans. 3, 4, 5, and 4, 5, 6. The span will know what was the start time and what was the stop time. So it knows the duration. And each of those spans has also some additional metadata, and we're going to talk about that later. So if we can take a pen and paper and try to sketch some logical, let's say, operations that are happening, we can find the following. So we have service 1 calling service 2. So a client sent situation happened, client sent event happened, right? Service 1 being client of service 2 sent out at a given time certain request. Now, service 2 at certain point in time gets the request, right? So client sent, server received. Then we have server sent, which means that the service 2 has finished processing the request, is ready to send back the response. And we have client received. So service 1 gets the response, right? So we have those 4 events: client sent, server received, server sent, client received. Why do we do it? Because here we have network latency, right? So we often forget that you never, let's say, the network has latency, that it's not the case that you send out a request and you immediately have it processed on the other side. There's this network latency that you have to take into account. Also, network is not homogeneous, so you can have network latency, a different one, on the response side. Right, so these are, with those events, knowing the timestamps of those events, you can calculate the network latency. You can also calculate the server processing time, right? So the difference in time between server received and server sent is actually the server processing time. The difference between client received and client sent in terms of time is the client processing time. So having those 4 events, you can calculate quite a few things. So now, is it that simple? So for a single trace, what has to happen is you have to have some sort of a framework that will, let's say, initialize the trace, the span, logically, and is able then to instrument your libraries that, for example, send the requests to propagate the headers, like through the headers, the tracing content, the context. And then on the recipient side, so for example, inside the application controller, you have to also have a framework that is able to, let's say, retrieve the headers and, let's say, create a tracing context out of it and propagate it, continue it further on. The same thing propagates between the controller and the service. So if the service is executed in a separate thread or using your favorite framework, you have to be sure that this, let's say, context propagation happens properly between those threads on those frameworks, right? Same thing is related to application service calling service 3 and service 4. If it's a different framework, again, it has to be instrumented so that the spans are being created and context propagation happens. Okay, so let's come back to our logs. So this was the case that we were creating logs, and the logs were supposed to be sent out to the log store. So let us assume that we have some sort of a solution, a framework that is taking care of, let's say, doing the context propagation and also instrumenting the logs, because to the left, you can see that we have trace ID. And then also we could do it something like this, that once the span is finished, which means that the operation is finished, the framework will dump out all the information related to the span, saying that this is a trace ID, the span ID, it started this time, it stopped at this time, the duration was that, there was such metadata. Most likely it's going to be in a JSON format so that the the recipient of those logs is able to parse them properly. However, a different approach is that you don't put it in the logs, you create the span objects and you push them out to something called a span store. And then you can, present it in a nice way that you had the production dependency graph, so you see exactly which service was calling which one on production. And you can also see the whole trace, which means that for this particular flow, it took 1.32 seconds. And you can see that service 1 is calling service 2, and service 2 is calling service 3 and service 4. And you can see which HTTP methods were used, etc., right? You can also click on a particular span and have some additional information related to the span. And if you have a good system to which you're sending out this kind of data, you can easily jump from the traces to metrics and the other way around, and preferably logs as well. Okay, so Jane says, that's pretty cool, but I have a hunch that if, let's say, the system is always the slowest for a given meme type. By the way, there's a question in the chat, will there be a demo? Yes, there will be a demo. So Jane says, yeah, I feel that there's a special meme type for which the system is always the slowest, and she would like to visualize only a subset of traces, because imagine that you have a gigantic load and you have to, scroll and search for this particular trace. In case where you feel that you want to see only a subset of those traces. So I remember when I said that there is this metadata part. So having the metadata part allows you to, for example, provide key value pairs of things. For example, what kind of a meme it was. So for example, here we say that it was a type meme. The type of the meme was a cat, right? So we attach a key value pair called a tag. Now, a tag is not propagated over the wire. So if I put a tag on a span 1 to 3, it's going to be related only to service 1 because it's not propagated over the wire. However, it's still valuable because if it's either dumped in the logs or present in the span, we can then filter over those things. So here we can see that we have a meme cat because I put such a, or Jane did, put the tag on the span, and then she said, hey, I'm searching for only those memes that are cat related, and assuming that I had hundreds of traces, now I can see that I have only 3, and I can reason about those 3 traces. Okay, so Jane says, oh, this is pretty cool, but I want to go further. So what I would like to do is to reuse the one set metadata for the process. So I want to propagate it over the wire because at any point in time, I would like to know the meme type. So remember, we talked about tags. They are not propagated over the wire, but baggages. So you set the baggage, you can set the same value, meme cat in service 1, and via the baggage, it gets propagated over the wire to any service downstream. So that way you can say in service 4, hey, what's the type of the meme? And then you get info that it's cat. So Jane says, I sense trouble. I really like the idea of distributed tracing. This is really cool. However, I have a lot of apps, I have a lot of servers, I have a lot of instances. I would like to start sending traces for all apps from all servers, and I'm starting to wonder about the data traffic. Like, I mean, this is going to be a lot of information being passed from my servers to some sort of a system that will gather this information, and I would prefer the system not to actually break. So we have this case, a lot of instances, a lot of servers. And this is a lie. I don't have that many spans. Most likely I have that many spans. Okay, this is also a lie. Most likely I have that many spans from each of the services. So I have zillions of spans, and I send them to a span store. And what can happen is that the span store breaks. So here we can introduce an idea of something called this, which is called sampling. So for example, we can say, hey, maybe I don't need all the traces. Let me trace just or send the traces to the span store, like only 10% or only a given rate. For example, 100 traces per second. Anything above that, I don't need it. I mean, of course, it will be visible in the logs. The context will be propagated. However, it will not be sent to the span store. Because Jane understands that latency visualization is used to measure repeatable latency. In general, I mean, if you have good infrastructure or a small volume of requests, you can sample 100%. However, mind you that you need to take care of the load, right? And if you're going to have a lot of traffic, there's going to be maybe an increased network latency. So Jane says, okay, what are the options? Like, what can I do? She wants to know what distributed tracing options are out there. It's 2021. And she has polyglot environment. So does it work for any language and framework? And what are the latency visualization tools out there? So there are certain standards on the market. We have OpenZipkin, which is a big community and a mature one. We have open tracing, we have open census, and open telemetry. The good thing is that all of them are open, which is also a little bit of a lie because open tracing and open census are deprecated, done. They are closed, so no longer you should say open tracing. Quite frankly, open tracing and open census have merged together to form open telemetry. So now you have OpenZipkin and open telemetry as de facto standards. So let's look in closer depth on OpenZipkin. So it's an extremely mature project, production tested, and gives you a multi-language support. It has 14,000 stars on GitHub, Zipkin as a project. So Zipkin is the visualization tool as well, right? Because OpenZipkin is the community. It's a organization at GitHub that comprises of many repos. And Zipkin is the server that allows you to render the distributed tracing information. So the first release happened in May 2016, but it was the first open source release because before that, Zipkin was part of Twitter. And I have no idea when it was created then in Twitter. So there is the Java library that allows you to, let's say, control the lifecycle of traces and spans. Such a library is called a tracer. So if we're talking about the tracer, a tracer is a library that creates spans, stops spans, reports spans to external systems, etc. So the one for Java that is open, let's say Zipkin native, so to say, is Brave, and it was first released in April 2013. I don't remember if back in that day it was still in SoundCloud. For sure, Brave is related to SoundCloud. And it has 2,000 stars. Now, OpenZipkin is using a default propagation format called B3. And B3, this is interesting because the original name in Zipkin in Twitter was called Big Brother Bird. This is why it's called B3. And these are the headers: XB3 trace ID, XB3 parent span ID, etc. There's also another way of doing this, which is a single B3 header that has hyphen separated values like trace ID, span ID, parent span ID, and whether it's sampled or not, as far as I remember. You can read the specification. However, you can translate from other propagation formats to B3. So Zipkin can work with other systems. So you could have part of the apps, let's say using one system, the other is using the other, but you have to do some sort of a translation at a certain point, right? And it's supporting multiple languages like C#, Go, Java, JavaScript, Ruby, Scala, PHP. These are the default ones that are supported by the maintainers of OpenZipkin, but also many other are community-driven. Now, OpenTelemetry. So OT was open tracing. OTel is OpenTelemetry. So it's new, it's a multi-language, and it's CNCF oriented, right? This is the main difference between the two. And now OpenTelemetry at the point when I was creating this presentation had around 800 stars, and the first milestone release happened in November 2019, the OpenTelemetry specification, because there are different repos. There's like the language specific ones, the specification ones, and there are various parties working on each of them. So spec has 1400 stars, and first release happened in June 2019, a milestone one. Now spec is GA, it's already 101 as far as I remember, but at the point of February 2021, there was no language that was GA. From what I know, Java should be GA soonish. So what OTel wants to address are problems of logs, tracing, and metrics at the same time. So their concept is such that you take OpenTelemetry and you can solve those three problems at the same time. As far as I know, the specification, the GA version of specification is GA for tracing, for sure not metrics. Metrics are in alpha. So tracing is GA. I don't remember the logs, but for sure tracing is GA. The other parts, not necessarily. And it supports various propagation formats because OpenTelemetry is supposed to be, let's say, native to the industry, and it's supposed to work with various other, let's say, applications that are using given formats. So, for example, Jaeger, OTLP, Zipkin, Prometheus, W3C. There are various formats that can be used. Supported languages: Java, C#, Go, JavaScript, Python, Rust, C++, Erlang, Elixir. Now, latency visualization tools, because you want to visualize this right, somehow. So one of them is VMware Tanz Observability by Wavefront. So all of the screenshots you've seen until now were coming from that tool. Another one is OpenZipkin. So this is the UI of OpenZipkin, showing you some sort of a trace. Another one is Jaeger, that was heavily inspired by OpenZipkin. And there are other APM vendors that you could, consider. I'm mentioning only a handful because there are really, let's say, a lot of other ones. Typically, those vendors give you an agent that you should be running. So an agent that is instrumenting your running code, and it's, let's say, creating the spans and traces for you. Okay, so the question from Jane is, what about metrics? Because she, at this point, she is writing Java and Spring-based apps. The question is about metrics. So Jane wants to know if there's anything that she can use related to metrics with Java and Spring. And the answer is, yeah, you can use Micrometer, which is actually not related to Spring at all. It's related to Java. And you can use Springboot Actuator, that is related to Spring. So let's talk about Micrometer. It's vendor-neutral application metrics facade. First release happened in February 2018. So it's a simple facade over the instrumentation clients for the most popular monitoring systems. The idea is such that you instrument your JVM-based apps without vendor lock-in. So regardless of whether you're using Wavefront, Prometheus, New Relic, Datadog, and anything else, you abstract this completely using some sort of an API, and then you hook in the dependencies. And for example, if you hook in Springboot Actuator, you get Micrometer and let's say Springboot native support for metrics. And then via various reporters, for example, you attach the Wavefront starter, and automatically you send metrics to a Wavefront or Prometheus or New Relic or whatever. That's the idea of Micrometer, that you don't have the vendor lock-in. Now, what is Springboot Actuator? We mentioned at a certain point when talking to Jane, that would be great to have this option that you start your app and the app is able to produce some sort of metrics or some sort of information about itself. So Springboot Actuator provides this. So it can enable production-ready features, and it allows you to choose how you manage and monitor your application. You get auditing health and metrics gathering automatically. So the module called Springboot Actuator provides all those features. And if you add the Springboot Starter Actuator, you can enable them by adding this dependency, and you get a micrometer out of the box. What about tracing for Java and Spring? So if she's using Java and Spring, what kind of distributed tracing tools are out there? So Spring Cloud Sluff is the way to go, in our opinion, and mine especially, since I'm running the project. So what is Spring Cloud Sluff? It gives you distributed tracing support for Spring Boot applications. First release happened, it's more than 5 years ago, so quite some time ago. So version 2x worked directly with OpenZipkin Braves API. So when you looked at Sluff's code and when you're attaching Spring Cloud Sluff, you had to use OpenZipkin Braves API directly. So version 3x, which was released at the very end of last year, as far as I remember, that means that what we did is we created some sort of a bridge. So we created some API, and we were able to bridge from this API to a given tracer, right? And what you can do is just you plug in the library, you configure it, and you're done. Okay. So what you can do is how Spring Cloud Sluff works is that you have different instrumentations, different, let's say, transport layers like messaging, batch, HTTP, etc. And we have Sluff instrumentations. So Sluff has some sort of this API that is instrumenting the way the messages are flowing in your system. Now, this API has some sort of bridges, for example, OpenZipkin Brave. So this is coming out of the box, as I mentioned. And we support also OpenTelemetry. And if you have anything else, you could apply whatever you really want. You have to provide the bridge. OpenTelemetry is incubating. Now you have the reporter bridge. So the moment the let's say span is closed, you have to report it to some sort of a system. For example, OpenZipkin or Towns Observability or whatever else. Those actually come come out of the box. You can bridge to other reporting systems either via Brave's extension points or OpenTelemetry bridges or configuration, right? Yeah, there was a question in the comments because I can't really answer all of the questions. Where is my mouse? Oh, there it is. Is OpenTelemetry supported by Spring already? Yeah, OpenTelemetry is an incubating project that you can add. And we are working heavily with OpenTelemetry people. They're also contributing to our code so that we are really up to date with their changes. Okay, so once the let's say the span is closed, we are sending out a span to the span store. Okay, VMware Towns Observability, we're going to be using that for the demo that I'm going to present you in a second. In general, it's an enterprise observability for multi-cloud environments, but why am I showing that is, of course, one thing, it's by VMware. The second thing is, I think it's pretty cool. And the third one is, if you want to try it out, it's free, right? So if you have a Springboot app, you can try it out for free. Okay, so let's check it out. Let's do a demo with Micrometer, Sluff, with Towns Observability and log correlation in action. So what we're going to be doing, we have 4 services. I have 4 services running on my machine, and I will be creating a new one, presentation service. I will send a request from presentation service to service 1. So we're going to be showing correlation, log correlation. So we're going to see hopefully 5 services there, or assuming, I mean, most likely I'm going to have some network issues because I've seen those previously, so at least a subset of those. But if I don't see all of them, I'm going to show you that in the logs, the correlation context was actually propagated properly. We should see the metrics and we should see the trace as well. So time for the demo. Okay, so what I'm going to do is I'm going to go to start.spring.io. So if you don't know what that page is, it's the page where you can generate a project that is Spring Boot based or Spring Cloud based. So what I'm going to do is I'm going to create a presentation service. Let me. Okay, so we're going to create a Maven project, language Java, Spring Boot 243, whatever, and let's add some dependencies. So first one is Sluff. The second one will be web, because I'm going to have, so Sluff is the distributed tracing for Spring Cloud Sluff. With Spring Cloud Sluff, but distributed tracing via logs, and it will propagate tracing context. Spring Web, because we're going to be using REST templates, and we're going to have a web controller, REST controller. We're going to have the actuator. So we want to add the metrics. And last but not least, we want to send information to Wavefront, because we can, and you could pick also, if not Wavefront, and want to play with this stuff locally without going to the cloud, you could pick a Zipkin client. Okay, so let's generate this. Yeah, let's save it, presentation service. Let's unzip it. Okay, let's open the project. There you go. We're opening the presentation service. What we have there in the palm is Spring Boot started 243. We have the presentation service. We're using the latest Spring Cloud version. So for those that were using Spring Cloud, it can be a great difference, because we used to have, let's say, named versions like Hoxton, Ilford, actually Ilford not, but Edgeware, Greenwich, Hoxton. And now we have the, let's say, calendar versioning. So we have 2020, that was the version of when that train was released, and we have 01, which means that we had already 00 and 01, which are the patch releases of that train. We have all the starters out there, and 2 bombs, the cloud dependency bomb and the Wavefront bomb. So what I will add are 2 additional dependencies, because I will be piping my logs via logs-logback encoder and logs.io logback appender, because I'm going to be publishing my logs to a system called logs.io that gives me essentially Elk in the cloud. So I'm adding this. Let me add some properties. There we go. Application properties. So I have my Spring application name, which means the name of the app is presentation service. Wavefront application name. This is, let's say, a logical name of the whole system, or a subset of that system. So let's say I have a slew of documentation apps system that comprises of the current 4 apps. I'm going to be adding the 5th one. The name of that service within those apps is called slew of documentation apps. The name is presentation service, right? Now I'm going to comment those 2 outs for the time being, because I'm going to show you how you can, if you want to, of course, demo Wavefront. We're going to generate a token and a URL for you. I have a token already. This is why I had it prepared here, but I will comment it out for a second. So now a little bit of coding. Very simple coding. First, I have a REST template bean, because I'm going to be sending out a request. And here I'm creating a presentation controller that essentially is using SLF4j for logging. And I have a REST template that is a bean. It's being injected, and I'm going to have a single endpoint that's going to print some stuff and send a request to another app that is running on my system. And this is this service 1 app, right? Because we're going to send a request from presentation service to service 1. So now, if I run this app, what should happen is, assuming that everything works fine, is that in the logs, you can see that you have some sort of a token and some URIs, and you can connect to your Wavefront dashboard using this one-time use link. So if you want to check it out, we will generate some information for you on how to actually play with this. But I'm not going to do that. I'm going to, let's say, show you an existing situation, because I already have a token. Why? because I want you to see all the 5 apps. This is why I had to use the token. So what I will do is I will run, ensure that I'm using Java 15, and I will run the app. So this is Springboot run. The app is running, very good. And now what I will do is I will curl, or actually use HTTP. I will send a request to port 9876, and if everything works fine, we should be able to see a response that concatenates all the other responses. Okay, presentation service, hello from service 2, response from service 3, blah, blah, blah. Great. So if I go back to my logs, I can already see that the logs are have changed as far as the IDs are concerned. So here we can see that this identifier, the trace ID, was properly set. This is the span ID. This is the name of the app. So if I copy this, and if I go where here, I have my logs.io page ready, and assuming that the logs have already been sent, okay, we can see that some logs were actually sent, some didn't, for sure. Oh, I know why, because I forgot about one file. So we don't see service, the presentation service, because I've forgotten to actually attach the appender. So what I need to do is create another file, which is called logback spring XML. Logback spring XML, because we're going to modify logback. There we go. And what we have here is that we're using the default logging approach. I want to append some stuff to the console, but also I have the logs.io logback appender. And what I want to achieve is I want to send out in the JSON format the logs to logs.io. So this was the missing piece. Let's stop the app. Let's run it again. And hopefully this time we will see everything properly. Okay, and let's try it again. It's still working fine, which is great. Let's copy the ID. Let's go to Kibana. Hopefully it's already been sent. There you go. So we can see presentation service. So just by adding a dependency, you could have seen that I haven't added a single line like specific to distributed tracing. I've just added a dependency, and I get the correlation ID being propagated and span IDs being created, etc., etc. Right? So we do have the correlation context propagated. We have all the logs cut into pieces that we can reason about in a distributed environment. Now, if we go to the to Wavefront, if I search for last 5 minutes, now we can see that presentation service was added here. So if I click at presentation service, if I go to the dashboard, we can see the dashboard of, let's say, related to the metrics from the application. We can see the duration, the request rate, and some additional information related to heap size, number of threads, etc. So we could create some alerts around this. I'm not going to show you how to do it because it doesn't make a lot of sense, but you can do it. And also we can search for traces. So if we search for last 5 minutes, we can load the trace view. And there you go. We can see the whole trace. We can see that the presentation service called service 1, then 2 and 3 and 4. We can see the whole trace. We can see that it took around a second. We could click on a given span, and we get some additional information about the tags, the span ID, the trace ID, the operation names. If I go over here, we should also see which controller. So presentation controller took care of this particular request, of parsing that request, and the method used was called start. So as you could have seen, by adding dependencies, you just get stuff out of the box, and tracing works like a charm. So that was it from the demo. I'm quite surprised that it actually worked. So that's it from my side. Hopefully you've managed to learn what distributed tracing is, what log correlation is, how you can use it, What so I tried to be as generic, say, not language specific as possible. So I mentioned only Spring at the very end. So all the concepts I've shown you are not related to Spring or Java at all. So as I've shown you, OpenZipkin or OpenTelemetry are native to various languages. So if, for example, you have a Python app, there's the OpenZipkin Python library, you can use it. Then you are sure that the B-free headers are propagated. Then you can use a PHP app that is OpenZipkin compatible, and it will, let's say, propagate the trace. From those 4 apps that you could see in a second ago, 2 of them were OpenTelemetry. We're using OpenTelemetry. So you can use, Zipkin on one side, OpenTelemetry on the other. You have all sorts of, let's say, different approaches to the problem. And if you follow those guidelines, then things will just work out of the box, because you have to ensure that on both ends of the communication, you are using the same, let's say, correlation standard. For example, W3C or B3 or whatever. If you want to reach me out, you can ping me on Twitter or any other means that you're going to find me. And I guess it's time for the questions. So let me stop sharing my screen. I'm really happy that the demo worked fine. And time for questions.
Okay, so I think that's the only one question now. So about the Wavefront.
Oh, hi, Anna. Yes, Wavefront is not open source. You have to pay to use it. Commercially, you can try it out for free. You can use also other tools like Jaeger, OpenZipkin, or anything else like that that are fully open source. You can install them locally. So it's up to you to decide. But yeah, Wavefront is not open source.
Okay. So I can see a question from Krzysztof Suszyński. Is OpenTelemetry supported by Spring Cloud?
Yeah, so this is what I mentioned, that if you go to Spring Cloud Incubator organization, there is Spring Cloud Sluff OTel library that gives you support for OpenTelemetry. It's of course it's incubating because OpenTelemetry is not GA yet, and we're doing various breaking changes because OpenTelemetry is doing breaking changes. However, current breaking changes are completely transparent to the user. So if you've been using Spring Cloud Sluff OTel from the beginning, and as I mentioned, let's say we have only milestone releases, it's incubating, and I know that people are already using this, it should be really transparent to you until now.
Okay. So maybe, as I cannot see other questions related to the technology you showed, maybe you can answer that question, I think.
I knew it. So when I was doing the dry run of this presentation, I was doing it to my colleagues from the States. I had explained it every single time. So I already know that Morse is called walrus in English. So the idea is such that throughout the pandemic, for some reason, at least in Poland, there was this new national sport that you dive into, extremely cold water, which is not a problem really. But what happened on social media is that out of the sudden you could see like a lot of people with their hands above their heads and in hats being in water. So it's not only the case that you had to do it, but you had to tell everybody else that you're doing it. So yeah, so this was the idea of that meme.
Okay, so next question about the server receiving the logs is down. What's then?
Oh yeah, that's a very good question. I mean, it depends on how you set things up, right? You can have, let's say, various spots where you store the logs, because you can have various appenders. I mean, from the case in the case of what we've seen in my demo, I was directly sending the logs from my app to logs.io. However, in the cloud, and when you have a platform, your app shouldn't care about that. Your app should be actually piping the logs to system out, and then it's the platform's responsibility to do something with the logs. For example, it could take the stream and redirect part of it to an external source, and the other, I don't know, to some other place, like, I don't know, Drive and archive those. Maybe it's a business decision, because maybe you don't care that you've lost those logs, right? But it's a great question.
Okay, so I cannot see other questions. So maybe in the meantime, maybe if you have other questions, just write it down. But in the meantime, I will remind you about after party, and I think that David will send you. Oh, he sent you already the link to Google Meet. When after this event, we will be able to speak to. I am able to speak to Marcin now, but you will be able to speak to Marcin and to other members of our community to talk about this presentation. So as I cannot see the newer questions, I think that's all.
I would have one more comment, because I saw that there was this discussion about this presentation being at a Polish WJUG and being in English. So you answered why is the case. So if there are more people who are, let's say, unsatisfied with either my level of English or the fact that it was in English, for sure, ping the organizers and we can create, let's say, an unofficial or another session purely in Polish. I don't see any problem with that.
Yeah, I think I clarified that we wanted to spread our community in the world. So that was an idea. But if anyone has a problem and would like to hear that presentation in Polish, Marcin, thank you for this proposition. We will try to do our best. Okay, so thank you very much. Thank you, Marcin, for today. And hope
My pleasure.
to see you soon on the after party. Thank you guys, and goodbye.